All right.
Sometimes I study too much and more time I'll probably study.
All right. Fair enough. Yeah, right, yeah. Then there's the opposing viewpoint, yeah.
Well, ideally today I wouldn't have done anything.
Yeah, well, yeah, that's true. That's true. Yeah, it'll be interesting to see what the weather is after all these warm days in February, what our weather will be. Next week is spring break. And I posted some announcements concerning that. Your midterm is the following week. I will post a more formal announcement about when it is. It probably will be that Wednesday, but I'll let you know for sure. I don't know if I said otherwise in a previous announcement. I think I just said it will be the week following that. So it'll probably be Wednesday. It probably would be nice to have a session to review and all that sort of thing. Just because it's break doesn't mean that I'm not checking emails and grading and planning stuff. So by all means, if you run into questions or issues, feel free to email me. I won't be on campus. I'll be doing everything that I normally do when I'm not on campus, and that is grading and watching TV. All right. Yeah, sleep somewhere in there. Yeah. I did see a recent study that said some scientists, and who knows how they come up with these. I didn't read the details of the article, but some scientists said something to the effect that, the standard getting 8 hours of sleep at night in one long continuous piece is not really, natural for people. That people generally would rather take like a couple of sleeps during the day, and I am all for that. I definitely, I do typically stay up late and then catch a nap. I caught a nap before I came here today, and I feel great. It's like squeezing extra days in the week. All right, so this is like morning to me. All right. At any rate, a couple things I want to do today. One of them is to go back and talk a little bit about the example we had last time, because as we were leaving, people made some good points, and we went back and forth on a few things. And I mentioned to bring any thoughts that you had about it to class today, and we could maybe touch base on it. Did anyone have any thoughts or concerns or revisions in how you would handle that? Yes.
We had way too many. We should have more
Okay. The statement was made that we had too much going on inheritance-wise, and we might be better off implementing more interfaces. In general, that's decent advice. All right. Going back and thinking through it, we might have gotten carried away with that. All right. And without going into the specifics of which to eliminate, that's oftentimes a good strategy to take. All right. Other observations. Interfaces that we missed. Can anyone think of some other interfaces that we may have missed that would be important? Okay. Right. Things that have associated with them a contract. All right. And I suppose that could be anything, even something like I know, like on Apple products, you can buy Apple Care, which is like a warranty kind of, but it's like an extended warranty. It's more like a contract. It has terms and all that. I guess you could probably lump that together with your cell phone contract and things like that. So yeah, that would be a possibility. Also, you can get from many of the mobile things, you can get tablets on the same sort of thing, where you have a data plan and so on. Yes. Extra speakers could be one what? Okay. All right. I like the thought. I wonder if that isn't a little too specific. I would maybe, is there any way that we could change that? The statement was is have things like extra speakers, and because an extra speaker is something that you could use with a list of things. Yes?
Has audio ports.
Yeah, has, maybe describe the ports. Has audio port would be a good way to do it. Yeah, an accessory thing would be another good way possibly to do it. All right. Again, the point of it is that that exercise last time was more about thinking through the problem and thinking through it out loud more than coming up with a definitive answer, which we kind of can't do anyhow because we're not running a business and we don't know all the things that we might want to track. And those would be critical maybe in answering some of these decisions for us. All right. Other questions, comments before we leave this? Yes?
One thing I was thinking, a lot of the things that separate these were kind of attributes. And I just wondered if, like, storing that kind of information. I know we're doing programming.
Right. Right. The question.
How much behavior really is
Very good. Very good. Okay. Very good. Let me try to summarize that for you, and let me know if I'm misspeaking your summary. The statement was, first of all, you mentioned about storing stuff in a database, and absolutely, we kind of haven't gotten to that point yet, so we're not talking about it. We're instantiating these by like running test classes and setting the values, and you very well could be. But the other statement that you said. So that's fair enough, and that's a given. There would need to be some sort of persistence to these objects that we could just pull them up and so on. The other statement that you made is, you said something along the lines, and this goes back with the first comments that were made, about, gee, the differences between these things, they don't necessarily have too many different behaviors. They may just have some different attributes. All right? And because of that, maybe we don't really gain anything, or we don't gain much by creating an inheritance structure. In other words, we could say, yeah, a phone is different than a handheld gaming device, but for our purposes, what is relevant about those differences? Is it just simply a matter of attributes, or is there truly some behaviors that we are interested in? I mean, I obviously know in the real world there's a difference between a phone and a gaming platform. The question becomes then, is that a difference that is relevant in the real world? And really the gain of inheritance happens when you do inherit and you can pass down behaviors more so than attributes. All right? So it's possible you could have some sort of you could do something along these lines, and I know I don't want to go and repeat the same sort of thing that we did before, and design another giant solution. But you could have something along these lines. You could have an electronic class, electronic item class. Why is that so bright? There we go. An electronic item class that maybe had a list of electronic components. Maybe an array list of electronic components. And those would correspond to maybe the attributes that you had. I know one of the things that we said last time is, well, really a gaming console, that's kind of a computer, right? I remember when I first got my Xbox, reading about people that hacked their Xboxes, not 360, but the whatever it was, Xbox One, and they hacked it like to run Linux on it. So yeah, it's a computer, right? Now, it always amazes me when I see something like that. It's like, yeah, you could do it, but why? But anyhow, I guess it keeps people, people have fun doing it. There's a lot of things I do that people would say, why would you bother doing that? So, hey, more power to them. At any rate, maybe we look at electronic items as a class. This is, again, just posing the question. And then we have a set of components, an array list of components. And then we have a component interface, all right, and that gets implemented by processor, that gets implemented by screen, that gets implemented by disk storage, right? Gaming consoles have disk storage, right, just like computers do and laptops do. All right, or other kinds of storage. Maybe disk is too limiting because some of them have other sorts of storage. And battery maybe, and power supply, and audio interface, audio jacks and USB ports and all that. And maybe we assemble our electronic components as simply having an array list of these sorts of things, maybe along with other attributes. And then we can go in and we can look. And for example, if we wanted to know if we had a product that we wanted to know, will these headphones fit in this product, would look for the audio jack or the audio, what would you say, plug on the component. And I'm having a hard time with this today. Maybe there's an audio jack and an audio plug on that's a component. And maybe if we have an electronic item that is a computer, an electronic item that is a set of headphones, we look to see if the headphones plug matches the audio jack of the computer. All right? Or we have a stereo system that may have a different kind of plug. Does the plug match the jack of the audio system? Does the plug of the headphones or whatever? So this might be a different, flatter way to address these things. All right? And it still holds, right? And if you think about it, especially again, when we start looking at phones being like computers and tablets being like computers and gaming systems being like computers, it might make sense to have a flatter inheritance structure similar to this and just have a set of components. And then you can choose the things that are in common for it. You can set up a list of a component interface, and you can plug any of these components into this, maybe. And I don't know if that's exactly what you were getting at, but that's sort of what you led me to think. Instead of having a bunch of different classes that vary, maybe only in some specifics about what they have, and they don't really vary too much in terms of behavior. Maybe you have one class that has a set of components, and the components implement some sort of interface. I actually quite like that. I didn't think of that coming in. I was thinking along the lines of making a less inheritance, but that's a nifty way to do that. And again, it supports our philosophy of saying, inherit things only when there's really some sort of inheritance that's relevant. All right? Questions about this? If you think about it, almost anything that you add to this, is a component that you could go put on, and you could apply to a lot of different devices. Does it have, wireless internet potential, capabilities? My Wii has wireless, my Nintendo DS has wireless, my phone has wireless, and my laptop has wireless. You know, those are things that would probably appear on different places on the inheritance structure, but if we did it this way, it doesn't really matter. We would construct it that way. Yes? Oh, yeah. Yeah, I mean, there would definitely be more details, and we could go into more depth about that. The point is all these things would have a would be of the interface of component, and then I suppose we could go, and if we needed to subdivide these components further, maybe we add a layer of inheritance there. And again, we're not going too crazy with it, but you know, we could supply it that way. All right. What I want to do now is talk about a different sort of problem. All right? And I want to at least sort of brainstorm a couple potential different inheritance structures and interface structures and see if we can come to any conclusions about what's what. Again, we're handicapped sort of with the same thing that we were with this, that we would need to know a little bit more maybe about what's relevant and so on. I'm going to describe stuff that you can find in a library. All right? Stuff that you can find in a library. And I may combine, just for the fun of it, like my own library, you know, the Amherst library, with the library here at LC. All right? Okay. All right, what can you find at a library? You can find books. Now, you can find different kinds of books, right? You can find some books that you can check out. And you can find some books that are reference books that you can't check out. All right? There's certain books that are defined as reference books. You can use them in the library, but you can't take them home. All right? There are also magazines. And magazines can be the current issue, which you can't check out. Or it could be a back issue, which you can check out. There can be audio recordings. And video recordings. And my guess is that there are some of those that you can check out and not check out. Lastly, and it's always wild if you ever, like in our library, and you see like an anatomy student in there, they're like checking out skulls and leg bones and stuff like that. You know, they're not real, but they're like plastic. But you can go take them in the study room and see how your knee is connected to the other part of your leg and all that. Yes. Oh, I'm sure it's important. I'm sure they're not just doing it for a laugh. All right. I guess I wouldn't care if they were doing it for a laugh, right? But I don't think you're allowed to take a leg home or a skull home. I think you have to use it within the library. So we'll call this models. leave it at that for now. I don't want to make a monstrosity of a problem like we did last time. I think I got a little carried away on that one, but we'll try to keep it under control. Now, in my mind, all right, there's a couple of different inheritance structures that leap out of this example. A couple of different obvious options for how we could set up the inheritance structure here, how we could set up the class diagram. Would someone care to define one of the obvious choices? Yes?
Whether you can or can't.
Yeah. And we'll say circulating collection and reference items. So, one obvious one would be, I would imagine there's probably an item that's above everything. All right. And then there would be a circulating item and a reference item. And then underneath those respective things would be the things that you can circulate and the things that you can't. Yes? Well, we're getting to that because we can go a couple different ways, right? If we went this way, you're right. There would be circulating books here. That inherited from that. Circulating video. And over here there would be reference books. And so on. Now, if we followed through this sort of idea, what might some of your interfaces be? Is the mic on? Testing. Yes? Stuff like books and video and so on. So, your question is well taken. Could we have, how do I want to put this? You asked the question, we're going to have books under each. So let's make that our subclass, all right, and make interfaces for reference and circulating. Well, when we take our other option, we're then going to have reference material under both, all right? And you always have a choice of which you're going to implement as a inheritance structure and which you're going to implement as an interface. How do I want to say this? There's nothing intrinsically wrong with either approach. Either of these approaches could be the right way to do it. All right? Obviously, we have to pick one, so when we finish defining them, we would, we'll go through and pick one. So there'd be an interface for books, and circulating books and reference books would implement that. There'd be an interface for video, and that would implement that, and that would implement that. Now, what would the other way of doing this be? Well, the way that was suggested. Making books, videos, and what else did we say? Yeah, audio recordings and all that. Would make them. So maybe we have. So I can put. Include books and magazines in the same area because they're printed, right? I could say, just totally lost my train of thought. I could say printed material maybe. All right, printed material. Then have a magazine. And have a book. And then have a circulating book and a reference book, a current issue, and a reference, or circulating copies. All right? If that is intelligible. All right? Item, printed materials, magazines, current issue, circulating or back issues. All right? Book, circulating reference. And then we would have probably two interfaces here. Circulating and reference. And current issues would implement the reference. Reference books would implement the reference. Circulating magazines would implement circulating. Circulating books would implement that. All right? First of all right, okay, go ahead.
I don't understand why you broke the inheritance part and then put in those. I mean, why don't magazines and books implement those interfaces?
Because what's going to be different? Because a circulating book versus a reference book, you can't check out a circulating book. Therefore, I can't implement on a reference book object. I can't implement the methods. I don't want to implement the methods for circulation. What would some of the methods for circulation be? How long you have it out for? What's the fine if you're late? And so that. I can't implement those methods on a reference book because those things don't make sense for a reference book to ask those questions. However, I can say if I have a circulating book class, I can implement the method. Like maybe new releases are, there's $1 a day fine on, I know with videos, for example. With videos at my library, you get videos for a different length of time if it's a new release versus an older release, and I think the fine's even different. All right? So there could be some logic in there that would say, hey, maybe for a book it's always $0.05 a day. Maybe for a video there's some calculation on the kind of video it is, and do that. But I can't implement those methods on a reference book because if it's a reference book, it doesn't have those methods. It doesn't make sense to have those methods. All right? Did that clear that up? Yeah. Yeah. Do I need to implement magazine versus book? Do I need that layer of inheritance? I would probably say yeah, because there really are differences in behaviors of magazines and books. Magazines come out in a series, a periodical. They come out. You subscribe to a magazine versus you purchase a book. All right? So, for example, if I purchase a book, I own that book. I guess I could purchase another copy of it, but that's something else. I don't have to renew that book next year or they'll come and take it away. All right? Or something like that. Magazines, however, a library would have to keep track of when the subscription was done and all that. So it does seem to me like there's different behaviors associated with magazines than there would be with that. There would be, the issues that it would have, how often it's published, is it monthly or bi-monthly or quarterly. It seems like there's a lot of different methods associated with magazines than there would be with books. All right? Likewise, audio or video versus that. Now, the question then has to become, which of these do we take? Because there's nothing intrinsically wrong with either of these. There's nothing that, if we look at these on a logical level, can we say, oh, no, one of them is good design and one of them is bad design. They both essentially do the same thing, right? A reference book is both a reference item and a book. A circulating magazine is both a circulating item and a magazine. All right? So the question becomes is, which one of those relationships do we implement as inheritance? Which one of those relationships do we implement as an interface? Any ideas on that? How would you decide between the two? You don't have to give me an answer necessarily, but what questions would you ask? What would you try to find out to make you decide which one of those two structures to create? Look for differences in behaviors. And what would the differences in what would the behavior suggest if you examine the behaviors of these different classes? What would it suggest?
That you have your second diagram.
Okay.
Item and then
Right. Right.
separated.
So what you're saying is you would look to see which structure more closely modeled the behaviors that we were interested in. All right? And where we would get the most reuse of code and where there's the most common set of behaviors from that. Is that kind of what you're saying? Yeah. That's definitely one of the things that you would do, all right, when you're doing that. Now, another way to do it, again, is to sort of look at it from the real world, what seems a more reasonable classifying of these things. And I guess I would say, I don't know. I'm gonna fence it on this a little bit. But it does seem to me that there's definitely a bigger difference between there's more commonality between books, magazines, and the media that it is, printed media, than there is between reference and non-reference items. The only thing relevant about a reference versus non-reference is whether you can check it out or not. All right? And therefore, that would seem to be just an isolated set of behaviors that things have in common that they share, so it's worthwhile to implement an interface for that. All right? But it's not necessarily something where you're going to share a lot of behaviors and so on. All right, you won't really gain the benefit of sharing the behaviors quite so much as, because really, a book is a reference book. All that means is you can't check it out, right? And there might be a few other handful of restrictions. Something that's circulating, we want to be able to ask something that's circulating how long you have it for. What's the fine, for returning it late? And maybe one or two other questions. So that's not tons of behavior that we're going to share there. So that would seem to be, if I was doing this, if you came in and put the proverbial gun to the head and said you have to choose one of the two, I would probably use the book, the printed material, video designation, and then create an interface for reference versus non-reference. But again, we would really need to know this for sure. All right? Questions about this? Yes? Yes? Okay. That's a good question. Let me see if I can paraphrase your question. The question was something like, could I do this? Could I create an item class and have, let's say, books circulating? We'll just do this one branch of our tree. Circulating versus not circulating, or reference. All right? Now, yeah, thanks. Let me know if I'm getting your question right. So could we do something like this? Could we put in here a method that says, a checkout method. And maybe it include, how long you get it checked out for. And maybe it would include what the fine is for returning it late. And so on down the line. You'd probably make this an abstract class, and you'd probably make this an abstract method. And likewise with this. And you probably wouldn't implement that method on the book level, but you could implement it then on the circulating level and on the reference level. And the circulating level would have a how long method that would return, I don't know, maybe you get it for 28 days. And maybe the fine is 5 cents per day late. All right? Whereas in the reference, all right, because we've made this an abstract method, we'd have to put something in here for that, right? So what we'd have to do is we might have to do something like how long equals 0 days, and the fine may be 0. Could you do that? Yeah. In general, though, okay, so what would that function be?
Have an interface on the side so that if you're going to use something as something that can be checked out, use that interface for your function.
Repeat that. I think you lost me.
Have an interface for being able to check stuff out, an interface for reference things.
Okay.
Function for checking things out up in the item. Only
The interface?
yeah, only implement the interface on the things.
So we have a checked out item here. We have a checkout item here that goes to circulating. And we have a how long method here. What does that how long method return on this level? Pardon me? It would probably have to do something like make up something, like return 0, or maybe return -1. We're going to assume you can't do that if you don't, we're going to assume -1 means that, -1 or 0, I guess either one means that you can't check it out. Now, what's wrong with this? All right? What's wrong with this is I can still ask a reference object, how long am I allowed to take you out for? I can't use it polymorphically. I can't plug it into, like, I see what you're getting at now. It took me a second to realize what your question really was. By only implementing this on this level, I'd have the ability that I couldn't throw a reference book, all right, in an array list that consisted of checkoutable items. 1 second. All right, or circulating items. Because a reference book isn't a circulating item, I couldn't then pass a reference book to a function that only accepted circulating items. So I'd block sort of the ability to do that polymorphically. But the problem is I still have a method on there that allows me to ask a reference book how long, and my program has to be smart enough to know that if I have a library item, and I ask how long they can have it, that 0 or -1 means that you can't check it out at all. All right? In general, it's not good to have data mean two different things. All right? If I have a function that returns how long you can have it, and let's say, just for sake of argument, I return a -1 if I'm not allowed to check it out, and I return the number of days if I can check it out, then that function, the return value, actually means one of two different things. It means, can I check it out? And it also means how long I can check it out. And the flag of, the two meanings are only because we know something about that data and know something about that function. We should be able to interrogate that and just say how long you're allowed to take it out. And if it gives an answer, take it at face value, right? Thinking about it, let's say we returned a 0 or a -1. If you weren't careful, someone that borrowed a reference book to use in a library is liable to get a fine for it, all right? Because they took it out longer than 0 days. They took it out for 15 minutes, all right? So they're liable to get a fine for so much. If the code wasn't smart enough to say, well, wait a minute, 0 amount means that, it's not... it's not able to check it out. So you want to be careful for having data that means a couple different things. And I used to see that ages ago in ancient applications. A branch number of 999 really meant that it's not a branch, but it's a department of corporate. Or, gee, if the customer number is, usually they're 999s or all zeros or something. If the customer number is something, that's not really a customer that's transferring between two warehouses. You have to always be careful when you have a piece of data and in essence you're using it for two purposes. It's a customer number except sometimes it really means something else. And you'd kind of run into that scenario with this. So that's not necessarily a bad thing. But again, that would be something that I wouldn't want. I would prefer to do it some other way. You had your hand up a while ago?
I forgot about fees, but I was thinking, I won't forget that reservation times in the computers at the library for the models.
Okay.
Whether that could count as how long, but I forgot, I don't. And have it stayed underneath grab if it's a reference or not.
Again, I think that's a lot more involved and complex way of doing that. The whole notion of object-oriented is that you don't have to have sort of this funky code that looks at this or looks at that, that it really works in a much more seamless way. Now, here's a question that someone raised. I think the fellow isn't here today. I forget his name. Is that Joey that sits in the back usually? Raised about their thing is, could there not be a Boolean? Maybe we do not have. Maybe we have an item class and we have a book. And instead of two classes, two subclasses underneath it, we have an attribute of this that says is a reference book. All right? And therefore, when it's instantiated, we set that variable. If it's a reference, it gets set to true. If it's circulating, it gets set to false. And then we have a get days or get how long. And again, the first thing it would do is it would test that if it's a reference. If it's a reference, it would tell you, no, you can't check this out. Now, depending on exactly how you coded that, you could run into the same problem that we ran into there, that your code would have to be smart enough to interpret that 0 means that you can't check it out at all. Now, the other thing you could do is, we haven't talked about exceptions yet, but if you tried to check out a book that was a reference book, you could throw a custom exception to say, hey, you're not allowed to check that book out. He was using it with regards to something with the example where we were calculating tuition. He either had a Boolean for the kind of student and the Boolean for, or the Boolean for the type of class, as opposed to making subclasses. There really is literally only like one small difference. Then having an attribute that allows you to select within that is a reasonable way to do it. That does sort of limit you, though. If you build that layer in there, then if there's other behaviors that are different depending on whether it's a lecture or a lab, a lecture class, or a lab class rather, can only be assigned in certain rooms, for example. So in addition to the fees being different for a lecture versus a lab class, there's restrictions about where you can have a lab class versus a lecture class. So, if there literally is just one tiny behavior, it may be okay to have some attribute that you'd test and set the value that way. But again, by creating the subclass, that does that. Questions about this? One thing that I wanted to explore a little bit is how could we implement something like, and again, we can just put in these items irrespective of where they fit in the inheritance chain. A book and a DVD. All right. We might want to know something about the language that it's in. Both of those have languages, right? A book, we're going to make the assumption, even though there might be some exceptions, all right, that a book it consists of one language. All right. A DVD, however, could have several languages. It could have several audio tracks. In addition, it could have subtitles in different languages. So, if we were going to implement some sort of language interface, all right, we might do this. Create our language interface. And we might create a function. And I'll review why I'm going over this particular example in a second here. We might create a function that says is language supported. And we could pass an argument of the language, and it would return a Boolean. Yes, it's supported. No, it is not supported. By implementing that interface, these two classes would each have to have an is language supported method that accepted a string as an argument and returned a Boolean. So both of them would need this. Now, the guts of that method, though, would be wildly different in both cases, right? Without writing the actual code, assuming that a book had only one language, the book would ask, gee, is the language of the book equal to the language that got passed in as an argument? If it is, then true, it supports that language. Otherwise, false. For a DVD, however, that would be more complicated, right? Because a DVD presumably would not just have one language, but it would have probably an array list of audio tracks, all right, an array list of subtitles, perhaps. And therefore, the DVD's implementation of this function is going to be totally different. For the book is if the book language equals the argument, return true, otherwise return false. Here what we would do is we'd have to loop through the audio tracks and see if one of the audio tracks was matching the language that we were asking about. And then we'd loop through the subtitles and see if the subtitles were that. Because, you know, maybe a movie only has one audio track that's in French, but maybe it has German, Spanish, and English subtitles. Or maybe it has an audio track of German and dubbed into French, but it then has the subtitles in English. All right? So you'd have to look through both of these. And you could go and scan through those arrays and see if the language that you got passed in as an argument matched either one of the elements that were in the audio tracks array list or one of the elements that was in the subtitles. Now, the point of this is the one thing that I really want you to remember is when you specify things as an interface, they may each implement the interface. Everything that implements the interface may implement it in wildly different ways, right? The code for whether the book has that language is very straightforward. Does the language of the book equal the argument? True, false. The code to do a DVD is more complicated. We loop through a couple of array lists and look for that language. When you have an interface, you're saying nothing about how that gets implemented. All right? How that gets implemented. All right? What you're saying is that this class is going to support this method. Now, how it comes up with the answer, that's entirely up to the implementation of the class. You know, what's stored in the class, you know, what the logic is, all that is different from class to class to class. It's kind of like the first sort of absurd example I gave about flying things. You know, if you're going to calculate the maximum speed, that might be a method on a flying things interface. Well, for a bird, it's going to depend on the wingspan and the weight of the bird and so on and so forth. For an airplane, it's going to depend on the kind of fuel you use and the size of the engines and all that. So there's calculations for both of them. It doesn't matter, though, the details of it. When you are implementing an interface, you're simply saying, these methods, this class is going to support. However it comes up with them, again, is specific to that class's implementation. Questions on any of this? All right. We'll see you up in lab then. Yeah. Should I keep the mic on or?
Well, I guess.
All right.
In the study guide,
Yes.
on the last item you have for programming, you'll be given a short programming exercise, or is it
Short.
short?
Yeah. Yeah, that should be short. I do apologize for that. Yeah, that's a good point. All right, thank you.